Let's do a quick recap as to whatever we studied in the previous class. So in the previous class, we studied about polynomials and its types, and then we also studied about the standard form of a polynomial. We studied that we can write a polynomial p of x in either decreasing or increasing orders of the powers of x. And then we also studied about adding, subtracting, and multiplying a polynomial. Therefore, in today's class, we will be learning about remainder theorem and factor theorem in detail. Remainder theorem, it states that if a polynomial p of x of degree greater than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is p of a, where a is any real number. So this is a definition of a remainder theorem, students. Followed by the remainder theorem. This is something which is very important. So if p of x is divided by x plus a, then the remainder is p of minus a, they are saying, which means this x plus a you have to equate to 0. What will you get plus a? If it goes into the other side, you will get minus a, right? So that's what they are saying. If p of x is divided by x plus a, then the remainder will be p of minus a. Similarly, if you take this, if p of x is divided by ax minus b, then the remainder will be p of b by a. How are they getting p of b by a? This is again they equating this particular expression to 0. Eventually you will get ax is equal to plus b, and then you will get x down, which basically you will get b by a, right? Similarly, if p of x is divided by ax plus b, then the remainder will be p of minus b by a. Likewise, if you again equate this expression to 0, what will you get? You will get ax is equal to minus b, and then x is equal to minus b by a. Eventually, that will be the remainder. That's what they are trying to say. Let's work out the exercise sums. Exercise 3.3. Question number 1. Check whether p of x is a multiple of g of x or not. P of x is given to us as well as g of x is given to us. How do we proceed is that we are supposed to equate this expression to 0. What will we get? X minus 2 equal to 0. We will get x is equals to plus 2. Then in the place of x, you're supposed to substitute 2 in this equation. 2 cube minus 5 into 2 square plus 4 into 2 minus 3. Then you're supposed to simplify. What will you get? You will get 8 minus 5 into 4 plus 4 into 2 is 8 minus 3. Then you have to simplify, and then you will get the answer as minus 7, which is definitely not equal to 0. Therefore, it is not p of x is not a multiple of g of x. In case if it was equal to 0, then you could say that p of x is a multiple of g of x. But in this case, it is clearly not equal to 0. So we are supposed to say that it is not a multiple of g of x. Now, let's move on to the next question. Number 3. Find the remainder when 3x cubed minus 4x squared plus 7x minus 5 is divided by x plus 3. So, how do we do this is, we have to write the given expression 3x cubed minus 4x squared plus 7x minus 5, like p of x is equal to. Then, what is given to us? We have to find the remainder when it is divided by x plus 3. As I told in the previous sum, you're supposed to equate this expression to 0. What will you get? You will get x is equal to minus 3. So wherever you get minus 3, you're supposed to simply substitute. P of minus 3 equals to 3 into minus 3 the whole cube minus 4 into minus 3 square plus 7 into minus 3 minus 5. Then you're simply supposed to simplify all of these, and then you'll get the answer. So you get the answer as minus 143. Therefore, the remainder is minus 143. Let's move on to the next question, number 4. What is the remainder when x power 2018 plus 2018 is divided by x minus 1. Now let us write this given expression as p of x is equals to x bar 2018 plus 2018. Then what is given to us? We have to divide it by x minus 1. There we have to find the remainder. As again, simply equate this to 0. You will get the value of x as plus 1. So wherever you find x, simply substitute it with 1. That's it. Then you have p of 1 equals to, in the place of x I have replaced it by 1. 1 per 2018 plus 2018, and you know 1 raised to any power will give back 1 only. 1 plus 2018 will be equal to 2019. Therefore, the remainder is 2019. Next question number 5. For what value of x is the polynomial p of x equals to 2x cubed minus kx square plus 3x plus 10 exactly divisible by x minus 2? Okay, again write this equation as it is. What are they trying to say? It is when, what are we supposed to find? The value of k when it is exactly divisible by x minus 2. You have to again equate this x minus 2 to 0. What will you get? You will get x is equals to plus 2. Therefore, wherever you find x, you have to, as usual, replace x by 2. Yes? And why are we writing 0 over here? Do you know? Why? Because they have clearly said that this particular polynomial is exactly divisible by x minus 2, which means it is equal to 0. That's why I have directly equated to 0, whereas I can equate this polynomial to 0 over here, and I have to replace x by 2, whereas 2 into, in the place of x I have put 2 power 3 minus k. As usual, I do not know the value of k, so I have written it down as it is, and then I have to write 2 power 2 plus 3 into 2 plus 10 equal to 0. Merely opening of the bracket has to be done. And then after solving it, I get 16 minus k into 4 plus 6 plus 10. I can club it up. Then what do I get? 32 minus 4k equals to 0. I can take this minus 4k to the other side. It will become plus 4k. And then if I have to find the value of k, this 4 will come down. It will become 32 by 4, which will eventually give the answer as 8. Therefore, the value of k is 8. Question number 6. If two polynomials 2x cubed plus ax square plus 4x minus 12 and x cubed plus x square minus 2x plus a leaves the remainder when divided by x minus 3, find the value of a and also find the remainder. So now if you see, we have been given two polynomials, right? So this is the first polynomial and this is the second polynomial. First of all, let me write this as p of x1 just to distinguish. Then I have written it down. What have they given? That it is divided by x minus 3. Eventually it means x is equals to plus 3, right? And then in the place of x, I will have to replace x by a. Basically substitute x by a. Then what will happen? Wherever x is, I have to write 3. So 4 into 3 minus 12, then 2 into 27 will give me 54 plus 9 into a plus 4 into 3 will give me 12 minus 12. Then plus and minus 12 will eventually get eliminated. Then I will be left out with 54 plus 9a. Now let me mark this as first remainder or first equation. Then let us write the second polynomial as p of x2. Then what have they told? It also needs to be divided by x minus 3. Therefore, what is the value of x? It is equal to plus 3. Again, wherever x is, I have to substitute x by 3. 3x cubed plus 3 square minus 2 into 3 plus a. A is unknown to me. Got it? And then I have to merely open up the powers. 3 power 3 is 27, 3 square is 9, and then 2 into 3 is 6, and then plus a as it is. Then after simplifying, I get this 30 plus a equals 30 plus a I get. Now let me mark this as equation 2 or R2, however it is. Got it, students, till here? Now if you look back into the question, they have told that it leaves the same remainder, which means both the remainders R1 and R2 are equal. Therefore, what do? I simply equate them. I simply equate these both. So what do I get? 54 plus 9a equals to 30 plus a. Now I can bring the constants on one side and the variable on the other side. So 9a minus a comes here and 30 minus 54 goes over there. Then after simplifying, I find the value of a. Therefore, what is my a? A equals to minus 3. Now, what is my remainder? It is basically 30 plus a. In this place, I have to substitute. What do I get? 30 in the a value of a is minus 3. 30 minus 3, I get the answer is 27. Next, we shall discuss about factor theorem. If p of x is a polynomial of a degree n greater than or equal to 1 and a is any real number, then p of a equals to 0, which implies x minus a is a factor of p of x. And then x minus a is a factor of p of x, which implies p of a is equals to 0. This is the factor theorem. Okay, again, this is very important, students. X minus a is a factor of p of x. If p of a equals to 0, which means x minus a, you have to equate it to 0. What will you get the value of x as a, right? That's what they're trying to say. And similarly, if x plus a is a factor of p of x, if p of minus a equals to 0, which means again x plus a equal to 0 you have to do, then what will you get the value of x as minus a. Similarly, in this case, ax plus b is a factor of p of x. If p of minus b by a equals to 0, how are you getting this minus b by a? Again, by equating this expression to 0, what will you get? Ax equals to minus b. Eventually you will get x is equals to minus b by a. Got it, students? So, and then x minus a, x minus b is a factor of p of x if p of a equals to 0 as well as p of b equals to 0, which means you have to separately equate it to 0. X minus a equal to 0, what will you get? X is equals to plus a. Likewise, x minus b equal to 0, what will you get? X is equals to plus b. Now let's move on to the exercise problems. Exercise 3.3. Question number 7. Determine whether x minus 1 is a factor of the following polynomial. Okay, let's do this. X cube plus 5x square minus 10x plus 4. Okay, you know what they're asking us to find whether x minus a is a factor of this polynomial or not. What are we supposed to do? Simply equate this. X minus 1 equals to 0. What will I get? I will get the answer as 1. Am I right? Then I have to simply substitute this in the place of x as 1. 1 cube plus 5 into 1 square minus 10 into 1 plus 4. Again, 1 raised to any power is 1 only, so I have to write it as 1. Then 5 into 1 is 5. 5 minus 10 into 1 is 10 minus 10, and then plus 4. Then I get 10 minus 10. I get answer as 0. Now, if I get the answer as 0, it means that x minus 1 is a factor of p of x. In case I haven't got it as 0, I have got it as something else, probably a negative number or a positive number or any other number for that matter. Then apart from 0, if I had got any other number, it means that so and so is not a factor of this polynomial. Yes, got it, students? Moving on to the next question. Using factor theorem, show that x minus 5 is a factor of the following polynomial. 2x cubed minus 5x square minus 28x plus 15. Now let us write this polynomial as p of x is equals to this 2x cubed minus 5x square minus 28x plus 15. And then what are we supposed to show? That x minus 5 is a factor of the polynomial. So which means x is equals to plus 5, right? Then again I have to merely substitute this in the place of 5x as 5. So what will I get? 2 into 5 power 3 minus 5 into 5 square minus 28 into 5 plus 15. Therefore 2 into 5 part 3 is 125, then 2 into 125 is 250 minus 5 into 5 square, which is 25. 25 into 5 is 125, then 28 into 5 is 140, then plus 15. After simplifying, I get the answer as 0, which means x minus 5 is a factor of p of x. I hope you got it, students. Okay, moving on to the next question. If both x minus 2 and x minus 1 by 2 are factors of ax square plus 5x plus b, then show that a equals to b. Okay, this is given to us. Now, how do we solve this? First of all, let us write this given polynomial as p of x is equals to. Then, first let us take x minus 2 as a factor initially. Then what will I get the value of x? I will get the value of x as plus 2, right? Then wherever x is, replace it by 2. And then they have told that these are factors, which means eventually the answer of this is 0. It is understood. Okay? Yes, students? Then I have to replace x by 2 as I said. Then a into 2 power 2 plus 5 into 2 plus b equals to 0. Then after simplifying, I'll get this 4a plus 10 plus b equals to 0. Now I want to keep the variables on one side and the constant on the other side. So I bring this plus 10 to the other side, it becomes minus 10. And now let me mark this as equation 1. Yes. Then what is the next factor? They said that x minus 1 by 2 is also one of the factor, right? So now let us also take that into consideration, which means what will my x value be? X minus 1 by 2 equals to 0. What will my x be? It will be equal to plus 1 by 2, right? And again it will be equal to 0. Why? Because they have clearly told that it is a factor. If it is a factor, then you have to equate it to 0 only. Then wherever x is, replace x by 1 by 2, right? Then I have to simply open up the bracket. What will I get? 1 square is again 1 only. So a into 1 is a. Then 2 square is 4. 5 into 1 by 2, which is 5 by 2 plus b equals to 0. Now we have this in fraction, right? In order to get rid of the fraction, let us multiply by 4 on both sides. What will happen? 4 over here will get cancelled, right? 4 by 4 will be. So I will be left out with a. Similarly, if I multiply this by 4, this 2 in the denominator will get cancelled, and then I will be left out with 5 into 2, which is 10. And then I have 4 into b equals to 0 into 4, which again will give me 0 only. I hope you got it, students. This is just one of the way to solve. We can also take LCM. However you want, you can solve. I found this easy, so I just did it like this. Then, as I told in the previous step, we are supposed to bring the variables on one side and constant on the other side. I get this as equation 2. Then what do? I simply equate both the equations. Why? Because eventually I have minus 10 over here as well as minus 10 over here. I can equate the left hand side, right? So after equating, 4a plus b equals to a plus 4b. What do I get? 4a minus a equals to 4b minus b. I am basically bringing a terms one side and b terms on the other side. Eventually I get 3a equals to 3b. After cancelling out the 3's on both sides, I get a equals to b. Hence I have proved. Yes, students. Moving on to the next question, number 12. Check if x plus 2 and x minus 4 are the sides of a rectangle whose area is x square minus 2x minus 8 by using factor theorem. Okay, now let the area of the rectangle be p of x. So basically this given polynomial, let us write this as p of x equals to. Then what are we supposed to do? When x plus 2 is the side of the rectangle, so let us take this, which means it is a factor. They have clearly said that we are supposed to solve it using factor theorem. So it is understood that x plus 2 is a factor or not, we have to check. That's what they are trying to say. So what if x plus 2 is a factor, which means I have to equate this x plus 2 to 0. What will I get? I will get as minus 2, right? So wherever x is, just replace it by minus 2 on both sides. So I'll get minus 2 square, minus 2 into minus 2, minus 8. 4 minus 2 the whole square will give me plus 4. Minus 2 into minus 2 will give me plus 4 minus 8. Eventually I will get the answer as 0. Therefore I have proved that x plus 2 is one of the factor. Now let's also prove the same for x minus 4. Okay, wherever x minus 4 is equal to 0, I have to put, I will get the answer as plus 4. Wherever x is, just simply replace x by 4 on both sides. What do I get? 4 square is 16, minus 2 into 4 is 8, minus 8. After solving, I get the answer as 0. Yes, I have got 0 for x minus 2 as well as for x plus 2, right? And therefore, I get x plus 2 and x minus 4 are both the sides of a rectangle. Got it, students? Now, let's do a quick recap as to whatever we studied in today's class. So, we studied about remainder theorem as well as factor theorem. So, what is remainder theorem? If a polynomial p of x of degree greater than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is p of a, where a is any real number. Got it, students? So, what do? We simply equate x minus a to 0. We get the answer as plus a, right? That is what they have written it down over here. Then we studied about factor theorem. We studied that if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then p of a equals to 0, which implies that x minus a is a factor of p of x. Then x minus a is a factor of p of x, which implies p of a equals to 0. So this is what we studied in today's class. So the rest of the homework questions will be sent to you all through Google Classroom. Thank you, students.